Hello students, and welcome to the first video as part of our summer engineering class. In this video I will introduce you to the engineering profession. So our objectives today are to define engineering and to think about the engineering field as we look down the future, which is what you should be doing. Okay, so let's begin with the first task, which is to come up with a formal definition of engineering. Look through these set of images here. Each one is a different engineering system or engineering machine, and think about what comes to your mind. We have the Golden Gate Bridge, we have an automobile, we have a cell phone, and this one might not seem so familiar to you, but this is what is known as a micro electromechanical system, or a MEMS system, MEMS. The dimensions of the features in this machine are of the order of a human hair, or maybe even 1/10 of the diameter of a human hair. Human hair is somewhere between 25 to 100 microns, so we are thinking about something that is of the order of 1 to 10 microns. These machines can actually find themselves inside a cell phone. So when you think through all this, of course we see that these kind of engineering systems can be complex in size as well as in what they contain. So you go from something very small to something very large, right? So what I would like to convey to you from here is that in order to construct an engineering system like this, you need large teams, you need different expertise, and you need an understanding of the laws of science. Okay, so with that in mind, let's ask the question about what is engineering. Think about how you would define engineering to a friend, a family member, or a grandparent, right? And this image here shows you that despite the complicated technologies that we hold in our hand these days, there are many parts of the world where people are extremely poor and even don't have running water coming to their homes. So this is a photograph from a poor part of India where there are children who are filling water so that they have clean drinking water. Thousands of kids die annually because of the fact that they don't have access to clean drinking water. So isn't this a problem that we as engineers should be solving? Well, it turns out that engineers and the way you want to define engineering in a formal sense is that engineering is a field that uses the knowledge of math and sciences, and this is gained by study, by experience, and by practice, and applies it for the benefit of humankind by utilizing in an economical fashion the materials and the forces that are available to us. So in other words, engineering uses math and science to improve or benefit humankind, and when I mean humankind, I mean the human species as well as the species that that we coexist with on this planet. Okay, for those of you who are interested, Appendix B of the textbook has 21 additional definitions that you can go through and see which one resonates well with you. Okay, so with the fact that engineers use math and science to solve problems that help humanity, we know that these problems are very complex, as you can see from a cell phone or an automobile. So it turns out that you might need to have a different engineer or a bunch of different engineers involved in solving one type of problem. It can be somebody who wants to manufacture and make things efficient in a manufacturing plant. You might be somebody who wants to invent new machines, in which case you might want to become a mechanical engineer. You might want to create new materials. You might want to become a materials engineer. You might want to fly, or rather send machines into air or into space, in which case you want to become an aerospace engineer. You want to design software and hardware, become a computer engineer. You want to design ways to communicate and also utilize and generate electrical energy. You might want to be an electrical engineer. You might want to solve grand problems in the environment. You might want to become an environmental engineer, and so on and so forth. There are many different fields, as you can see from this example here. The US government recognizes about 17 major fields and collects data on it. So what I would like you to do is to go to this website link below here and read about each of these engineering fields and what they are. The presentation of each of these fields is concise, so you can get a quick overview of each of these fields, and then as we go through this class, we will learn in more detail about what the different fields can do. Okay, so with that brief engineering introduction in terms of a definition, let's look at what engineering looks like in the future. Well, the first thing we can look at is, where are your peers going to in terms of an engineering degree. This is data from 2016, and it shows you that mechanical engineering is one of the most popular engineering fields to get a degree in, followed by electrical engineering. There's a typo here. This should be 16,165. And as you run down this list, you see that there are many recognizable fields that form a huge chunk of the degrees that engineering graduates are getting. Buried inside this column here, or this row here, where we say all other engineering disciplines, are the smaller fields like material science or materials engineering, petroleum engineering, environmental engineering, and so on and so forth. What is important is to look at the future, and one way we can do that is by looking at the Bureau of Labor Statistics data on what the employment is going to look like down the line, as well as what salaries are going to look like. So on the x-axis is a predicted employment change in each of the engineering fields, while on the y-axis we show the median annual wage. So the median wage tells you that at this particular wage value, you have half of the people getting more and half of the people getting less. Now, the good news is that each of these bubbles here represents a range of values in expected change in the amount of employment and the change in the amount of median wage. And generally what you can see is that most of the engineering fields are on the positive side of the growth axis, while they also have a fairly large range or spread in the median annual wage. So if I look at the civil engineer whose bubble is shown here, the median annual wage is going to be somewhere between $72,000 to about $92,000. Okay? So this is another way to think about the fact that engineers, as a field, engineering is going to grow, and the salaries are going to be pretty good. Now, another way to think about engineering is not in terms of a field, but in terms of a problem. And this is what the National Academy of Engineers has put out. They have identified 14 grand challenges for engineers and engineering as a field, and these cover every aspect of life, including things like making solar energy economical, advanced personalized learning, advanced health informatics, engineering better medicines, providing clean access to clean water, providing energy from fusion, and so on and so forth. So this is something else you can think about when you're trying to choose what type of engineering you want to do. So again, there is a link at the end of this video lecture to the National Academy of Engineers that talks about each of these 14 grand challenges. Now here's something else to ponder about in terms of the kind of engineer you want to be and the kind of job you want. We know, and there is growing evidence and there's growing concern that automation is going to replace many jobs. In fact, it's predicted that almost half of the jobs that are currently available will be taken over by automation. Well, that is certainly a worrisome aspect of automation. But the good news is that if you think about the last 125 years, automation has constantly been replacing jobs, but the number of jobs has actually gone up. And why is that? Well, think about it. If you look around you, just as an example, think about a yoga studio. maybe 20 years ago, there was probably one type of yoga that was being taught. But now you'll see that there are many different types of yoga studios available where we can go and learn our particular type of yoga, or the type of yoga that we want to learn. So this is kind of an example of how the number of jobs has actually gone up, because now we are creating jobs that are more and more complex and fine-grained and cannot always be done by machines. But at the same time, we are also creating jobs that are the interface between different types of machines. So a very good way to understand the good and bad about automation is through this TEDx talk. So please take a moment after this video lesson and go to this TEDx talk, which is linked here and in your lecture slides, and have a look at and listen to this TEDx talk to understand better the pros and cons of automation. So with that, I come to the end of this first video lecture. Make sure, as I said, to go through additional content such as chapter 2 of the textbook, which is where this content has come from, supporting lecture slides, links to the National Academy of Engineering website, as well as the Bureau of Labor Statistics, and also make sure to complete any activities that are related to this lesson, right, including any video presentations, group discussions, and homework. Thank you.